Hello, my topic is gravitational waves. So, to understand gravitational waves, we first need to understand how gravity works. We all think of gravity as, a pulling force, but Einstein thought of it in a different way. He said that gravity was due to the curvature of space and time caused by the mass of an object. So, consider this an object, and this to be space and time. So, this curvature caused due to the mass of this object is gravity. So now, if an object was traveling like this in a straight line in normal space, like this, now under the influence of gravity, its path would change and it would travel like this. Its path would curve, and this is what we think of as the gravitational force of attraction. Now, the area of the effect of gravity of this object is the gravitational field of this object. The general relativity predicts that just like water, ripples can also be created in space and time. And these ripples in space and time are called as gravitational waves. And these ripples, just like in water, move away from their source. So, if this were their source, they would move away from it. But how are these ripples created? Now, these G waves can be created by system of two stars or system of two massive black holes or two massive stars. Now, this happens due to the interaction or interference of the massive gravitational fields of these objects. These are their gravitational fields, and their interaction would create ripples in space and time. Now, gravitational waves can also be created by movements like spinning or rotating of stars or black holes in space. This happens because the effects of gravity don't travel outward at the speed of light. So, for example, if our sun were to shift a few hundred kilometers towards right, it would take time for its gravitational field to shift, causing distortion in its gravitational field. Now, if our sun were to move continuously back and forth in space, there would be a continuous distortion in its gravitational field, back and forth movements, causing formation of ripples in space and time, and hence gravitational waves would be created. We can easily see that a wave has passed by looking at how nearby objects or particles behave. For example, let's take a water wave. So if a water wave passes by, then an object or a ball kept at its surface would move up or down with the wave, and there would be change in its position observed. We will observe a change in its position. It would move up and down, and hence we can say a water wave has passed if you see a change in its position. So, for example, similar things happen with gravitational waves. We take a person free floating in space. So if a gravitational wave passes by, he would move back and forth in space. So the distance between two objects would change. Here the distance would end up decreasing, and here it would end up increasing. This is due to compression and expansion of space. Now the LIGA observatory works on a similar concept. It detects these gravitational waves by a similar concept. So it consists of two long arms, each having a very sophisticated, expensive mirrors at each end. Here there is a light sensor, this is a laser shooter, and this splits the laser beam. So here it will shoot a laser beam. It will be split into two light beams, each having equal wavelength. So it would take them equal time to travel back and forth through this arm and come back at this intersection. So when they meet up at the intersection, they meet up in such a way that they equalize each other's effect. So no light is detected. Yeah, these are the waves. So no light is detected by the light sensor here, this light sensor. But if there were gravitational waves, then this distance would increase due to expansion in this case and compression, and similar thing would happen with this distance, and hence it would take different times for the light to travel back and forth, and they would not meet up here. So hence some light will be observed. So if significant amount of light is observed at this light sensor, we would say that gravitational waves we have detected gravitational waves.